Hello there. Welcome to part 2 of trigonometry. Earlier on, you will recall we said that trigonometry deals with measurements in a triangle. Now, the things we measure the corners in a triangle. We also measure the length of the sides of the triangle. So we measure the corners in degrees or radians, and we measure the length of the sides in centimeters, millimeters, meters, kilometers, if it's a really big triangle, and so on. Now, to help us with these measurements, we are going to be employing what we call trigonometric ratios. Now, what are these? Trigonometric ratios describe the relationship between the corner measurements, which are angles, and the side measurements, which are lengths, in a triangle. We are going to start this with right triangles. But first of all, we have to talk about the Pythagorean theorem, which tells us about the relationship between the lengths of the sides of a right triangle. So, given a right triangle, such as shown, with one of the angles is theta, the other one is a 90-degree angle, the length of the sides, we can say that the one side is y, the other one is x, and the longest side in the right triangle, we'll call that z. That is called the hypotenuse. Now, the relationship is as follows. The square of the hypotenuse is the same thing as the sum of the squares of the two other sides in the right triangle. This means that we can solve the equation that has ensued as a result of this relationship. For example, if you have a triangle as shown, you have the hypotenuse is unknown, and you have two lengths of the sides, 4 and 3 as shown. How do we find z? Well, the relationship is that z squared equals to 4 squared plus 3 squared. Therefore, z squared is 16 plus 9. Z squared is 25. And therefore, z is the square root of 25, the positive square root of 25, which will be 5. Or given another triangle here, the triangle the orientation is a little bit different, but you can see the right angle over there. So that means your hypotenuse is 13. And you can use the same Pythagoras formula. 13 squared is equal to 5 squared plus y squared. So the square of the hypotenuse is the same thing as the sum of the squares of the two other sides of the triangle. If we solve the equation that has ensued, you have 13 squared minus 5 squared, which is equal to y squared. And then we can have 169 minus 25, which is equal to y squared. And then we can have the square root of 144, which is 169 minus 25, the square root of 144, which will be 12. Therefore, the missing length of the side is 12. Now, let's talk about trigonometric ratios properly now. We said that these describe the relationship between the corner measurements and side lengths of a triangle. The corner measurements, which are the angles, we will call theta. Now, we can use all sorts of symbols, but we'll use theta here. And the side lengths, we will use x or y. Now, the trigonometric ratios, we are going to define them in terms of points on the terminal arms of some angle theta. So, for example, let's pick a point on the Cartesian plane. We said that this point can be defined in terms of the x-coordinate and the y-coordinate of this point. So this point has coordinate x, y. We can draw in an angle theta as shown. So we can say it also in a way as follows, saying that given an angle with a terminal arm, we can pick a point on that terminal arm. Call that point x, y. The angle formed between the initial arm and the terminal arm is theta. We can complete this picture by drawing in a right triangle. So the length of the right triangle, the base length of the right triangle, you can call x. That is the distance from 0 to that point. And the distance from 0 to the y-coordinate, you can call y. The length of the hypotenuse of the right triangle, we will call r as shown. By Pythagoras, r squared is equal to x squared plus y squared, and solving for r will mean we'll take the positive square root of x squared plus y squared. That is by Pythagoras. Now, the trigonometric ratios, there are 3 of them: the sine, the cosine, and the tangent. The sine of the angle theta will be defined as the y-coordinate of the point on the terminal arm of the angle divided by r, the length of the hypotenuse of that right triangle, which is the same thing as the length of that terminal arm. The cosine of theta will be defined as the x-coordinate divided by the length of that hypotenuse side. And finally, the tangent of the angle theta, noted as tan theta, will be the y-coordinate divided by the x-coordinate of the point given in that quadrant 1. For example, let's pick a point on the terminal arm of angle theta. That point is 3, 4. Let us find the length of that arm, the length of that terminal arm. By Pythagoras, we know it's 5, but how is it 5? Well, r squared is equal to 3 squared plus 4 squared. So r will be the square root of 3 squared plus 4 squared. And then you can take the square root of 9 plus 16, which is the square root of 25, and that will equal 5. So r will be 5. And now that we know r is 5, we can talk about the trigonometric ratios of the angle theta. Sine of theta, by definition, is y over r, which is 4 over 5. Cosine of theta is x over r, which is the same thing as 3 over 5. And tangent of theta is y over x, which is 4 over 3. So these are the trigonometric ratios for that angle theta, where the point on the terminal arm is in the first quadrant. Please observe that the trigonometric ratios of all three, sine, cosine, and tangent, are positive in quadrant 1. You can see 4/5, 3/5, and 4/3. Now let's pick another point. Now let's do the mirror image of this point in quadrant 2. So we have -3, 4. Okay, it's the same point, but then the x-coordinate is the opposite one in the second quadrant. R will be the same, it will be 5. And how is it 5? If you take the square root of the sum of the squares, so you have -3 squared plus 4 squared, and you're taking the square root of that, you'll get the square root of 25, which will be 5 as well. And so therefore, sine of theta, by definition, is y divided by r, cosine of theta is x over r, tangent of theta is y over x, and their values are as shown. Again, please observe that out of all three, only one of them is positive this time. The sine of theta is positive this time. The other two are negative. So therefore, we will indicate that in the first quadrant, all three trigonometric ratios are positive, and in the second quadrant, only one of the trigonometric ratios, the sine, is positive in quadrant 2. And then let's pick another point in quadrant 3. The point we are going to pick is -3, -4, which is the equivalent point of the other two in quadrant 3. So x and y are both negative values. The angle we have included, we are drawing that angle in the opposite way. In other words, it's probably a negative angle now because we're drawing it clockwise. But we'll call it theta. It doesn't really matter. The definition is still the same, and we'll find r. R is 5, like in the other cases. So sine of theta will be -4 over 5. Cosine of theta is -3 over 5, and tangent of theta is -4 over -3. So if you divide two negative numbers, you get a positive one, which is 4/3. So therefore, you can see that only the tangent of theta, tangent ratio, is positive in quadrant 3. And finally, we can take a similar point in quadrant 4, which is 3, -4. The angle there is theta, r is 5, and so the trigonometric ratios are shown. Sine of theta is -4/5, cosine of theta is 3/5, tangent of theta is -4/3. And you can see that only the cosine is positive in quadrant 4. Now, what do this mean? Now, the precision that we have just looked at, what does this mean? Well, this implies the following, that whenever you are having a point on the terminal arm of an angle in any of the four quadrants, so if that angle theta is in quadrant 1, all the trigonometric ratios are going to be positive. If that terminal arm is in quadrant 2, only the sine will be positive. The cosine and the tangent will be negative. If that angle theta is in quadrant 3, only the tangent of the angle will be positive. All the other two will, or both of the other two will be negative. And finally, if the angle is in quadrant 4, only the cosine will be positive. The other two will be negative. So, why don't you try your hands on the following example, like we've done in the previous videos. Please pause the video now until you have completed this example, and when you have finished, you can continue the video to see what I have done. So please go ahead and pause the video now. So, what did you do? Well, here is what I have done. For the first triangle, we will call the missing side, the hypotenuse, we'll call it r. And by Pythagoras' formula that we talked about before, r squared will equal 5 squared plus 2 squared, which is the same thing as r squared equals 25 plus 4. So r squared is 29 and r is the square root of 29. And for the second triangle, the Pythagorean formula applies as well. The hypotenuse is given. We can write that relationship as 10 squared equals 6 squared plus y squared, and we can solve that equation by subtracting 6 squared from both sides. If we follow through on that equation, on the equation, we will see that y is equal to 8. And for the second part, we pick the terminal. We'll pick a point -1, -1 on the terminal arm of an angle. That angle will be in quadrant 3. The length of that terminal arm r we can find by using Pythagoras, as shown. R is the square root of the -1 all squared plus -1 all squared. The result there is the square root of 2. And now we can talk about the trigonometric ratios of theta. Sine of theta is y over r, which is -1 over root 2, and your result is as shown. If you rationalize the denominator, because you don't really want root 2 as a denominator, your result will be -2 over root 2 over 2. Similarly, cosine of theta is x over r, which is the same thing as -1 over root 2. By definition, cosine of theta is x over r. So that's how, and then if you rationalize the denominator, you will get -root 2 over 2. And finally, tangent of theta is y over x, which is -1 over -1. Your result is 1. And finally, we have the point 2, 7. This point, you can draw that, you can locate that point on the terminal arm of an angle in quadrant 1. So even if you draw that angle as a negative angle, it doesn't really matter, it will be the same thing. You can talk about the trigonometric ratios of that angle. But first of all, r is you can find by using Pythagoras, which is the square root of 2 squared plus 7 squared. Your result is the square root of 53. And then sine of theta you can say is y over r by definition. Your result is as shown, 7 over root 53. And if you rationalize the denominator, you will get 7 root 53 over 53. Similarly, for cosine of theta, the definition says that is x over r, and your result is 2 divided by root of 53. If you rationalize the denominator, it's as shown, 2 root 53 over 53. And finally, tangent of theta is y over x, which is the same thing as 7 over 2. So this concludes our video on part 2 of trigonometry.